so you should see a page with resources, right? So this is a hacking session, as I described in my blog, and the idea is, I'm going to talk about less known SQL monitoring things, right? Questions that often come up, but which are perhaps too low level or too specific. And I will upload the video to my YouTube channel, right? So I already have uploaded previous stuff there. If you want to get a higher level overview of how to read SQL monitoring reports, then I have slides here. In SlideShare, and actually I might show you a few when we do the intro. Maria Colgan, like a year ago, she wrote a really good article, and it's a pretty long article about how to get the most out of SQL monitoring reports, and it's a lot of details. So that's definitely, if you want to get an overview of what can be done with SQL monitoring, then read that as well. And by the way, next Wednesday I have another hacking session about my Ash scripts, right? SQL monitoring actually uses Ash under the hood as well in some places. So these are somewhat linked topics. Okay, so I'll paste the links. Let me see how to do that. Well, you can take a screenshot of this right now, but I'll upload the slides to SlideShare, the latest version. Then. And what I can do is I can actually send out the links after the session as well. Okay. By the way, I decided to take some time. Despite what I thought earlier, I decided to take some months to geek out and just go deeper into some technologies of interest. And because at Fluent we do a lot of low level stuff with Linux nowadays as well. And so then I thought that, hey, why not? Like, I'm gonna take 6 months and I'm gonna go really deep and just sort of formalize what I've learned over the last years into training material as well. So I'm gonna do my SQL tuning class, what I haven't done for 5 years. I'm gonna update it to latest version, and I'm gonna do it in October and November. I'm gonna do another advanced troubleshooting class in end of this year, and then the Linux stuff, what I've been doing over this last 4 years. I'm gonna put this knowledge into a class as well. So you can see more details here. Okay. Let's look into SQL monitoring topics, right? I'll do a very quick intro. So I'm not gonna do high level stuff really here. So I'm not gonna talk about how to get SQL monitoring reports or the typical ways that much. I'm gonna look into some of the specific issues or internal details you might have been wondering about. Okay, let's this is a typical example of a SQL monitoring screen, right? And let's start from the hacking session part, and let's see, when does SQL monitoring actually kick in, right? So I'm gonna use a couple of different screens here to show this kind of stuff. Okay. If I I'll actually open up a browser window as well. So this is my enterprise manager of my VM with Oracle 18, and here I have this. Well, I gotta log in again. Sorry about this. This is somewhat annoying, but let's get it done. I'm gonna go to the performance page. So again, as I said on one of the slides, this feature requires tuning pack and diagnostics pack licenses, right? And I'm just gonna click on the monitored SQL. And since I have this slider all the way to the end, and I don't really have much activity here right now, I don't see anything monitored in the last 5 minutes. Okay, so I'm not going to use the monitor hint yet, right? So so let's just say select full count star from. I know that this is a big table, right? And you know, that should run for a while. Just make this small lower, you know. Oops. Well, it was so I forgot to add the table alias. I think this guy ended up doing a really an index fast full scan because I forgot to add an alias t here. I want to do a full table scan, and I wanted to take a bit longer. By the way, SQL monitoring apparently kicked in for this query already. This query ran for only a few seconds. Let me actually do this as well. Set timing on, right? The query that picked the index fast full scan was apparently monitored. It ran for 5 seconds. And one of the reasons why you know, monitoring kicks in is that when a query is parallel, when Oracle decides to run the query in parallel, then, you know, parallel queries are, you know, deemed to be like long-running queries or heavy enough queries, so that SQL monitoring automatically kicks in immediately for parallel queries. So that's why we got monitoring immediately here, right? So, but let me just I want to do a serial query, so I'll just do select. I'm gonna clear the screen. So select full T. I'm gonna say no parallel as well, you know, and now I didn't forget the table alias. Now the full hint should be valid. Okay. So now the query is running. I'm gonna click refresh. Nothing. You see, about 6. Here it says about 6 seconds later, you know, this query showed up. So what I'm trying to demo here is, I don't know how well it showed, but when you run a query and it's a serial query, you see, it's a serial query, no parallel, then monitoring doesn't kick in immediately. It actually kicks in some seconds later, right? So, and the reason for that is that when you have very short running queries, you have like an OLTP system, and every query takes like 5 milliseconds. You don't want to do monitoring for all of these queries because they finish quickly, you know, fast enough anyway. And you know, or the main reason really is that if you monitored all these queries, where would you keep all this information? You know, if you execute 10,000 queries per second, you know, are you gonna keep 10,000 copies, 10,000 you know, SQL monitoring history structures in memory for every second? And you know, you would run out of memory, and you would have some latch contention in you know, there is a latch called real-time descriptor latch. You know, if all your 1,000 processes started writing SQL monitoring info into the VDollar SQL monitor tables, right, then they would all end up contending for this latch a lot as well. And you would need a lot of memory to keep all these short executions. So that's why if you look into parameters, so there is a parameter called SQL mon threshold, and this tells you that this is in seconds, right? That how many seconds of CPU and I/O a query needs to consume before monitoring automatically kicks in, right? When you run a parallel query, then monitoring kicks in automatically, you know, immediately anyway. But when you run a serial query without the monitor hint, right, then monitoring kicks in only after the query has consumed, you know, more than 5 seconds of total CPU and I/O time, right? And that's designed to avoid monitoring too short queries, you know, too frequently, right? So here is this parameter, and that's why, you know, let me just run this once more. Not sure if I can show it fast enough, but I run this query, and then I will go here and try to refresh, right? I run this guy. So refresh, nothing. Refresh, nothing. Refresh, nothing. Refresh. So I think my UI, the Flash UI, is not too good either. So there is a, as I often say, there is a reason why I often prefer scripts, just to see where the real data comes from. So now we don't see anything showing up at all. So that's weird. That's not what I wanted to demo, by the way. Let me just check the hash value. So the SQL ID is this. So I have a little script called x1, which is an experimental script which just queries $v$ SQL monitoring views, and it does find the query which started at this minute. This is my latest execution. I know that's what the clock says, and the data shows up here in the $v$ view. But the GUI, apparently the GUI has a problem as well, right? Now like a bunch of time later, I hit refresh. Now it shows up. And it took 18 minutes to run. Anyway, so what I wanted to show here is so apparently there is a GUI problem here as well. What I can do to avoid this GUI problem is if you read these references, I have a little script called XP, which is using DBMS. Let me just show it's DBMS SQL tune report SQL monitor. It uses such a function, and I'll just say monitor whatever is the latest query execution in this session. So when I run this right now, I see that the latest execution in this session is at 12:13, right? So this is like a text mode SQL monitoring report. I'm using this procedure or function, right? And now when I run this query again, what I should see that for 5 seconds, nothing new shows up here on the right side. But after 5 seconds, we see a newer execution. So let's try. So let's go. You see 1, 2, 3. Okay. You see a few seconds later, when I scroll up, I ran SQL monitoring for a few seconds, a couple of times in a row. It still showed old monitoring info. And then 5 seconds later, roughly 5 seconds later, the new SQL monitoring measurement had kicked in, right? Instead of 13 minutes after 12, it's 16 minutes after 12. Roughly you see elapsed time has been over 5 seconds, CPU and IO time. If you add it together, it's over 5 seconds, right? And again, this magical parameter, SQL mon threshold, controls that. Okay, so if I set this to a lower number, like number 1, then it should kick in after 1 second, right? I haven't really needed to change that, right? But because there are some other ways to get this kind of info as well. Okay, and when and obviously the way how you can force monitoring is you just add a monitor hint into a query, right? So if I highlight 12:16 now, I add monitor, right? I ran the query, I ran this monitoring command immediately, and immediately monitoring had kicked in. Okay, I have covered this on a slide as well, right? So that monitoring kicks in you can force it to kick in with monitor hint. But don't enable monitoring for every single OLTP query of yours, because you will just flood, you'll get a lot of latch contention against this memory area where this monitoring info is kept. Okay, so 5 seconds of CPU and IO time. Okay, so now let's do something else. And by the way, there is a question that the text mode monitoring info, does it show the same info as the HTML report or Flash report? Yeah, it's similar info, but the Flash report shows more info. This is just one text output. It doesn't, contain, you cannot click on things, you cannot drill down. So Flash has more info, Flash version. And I'll talk more about that as well. Okay, so now let's stick with when does monitoring kick in for once more. So let's say I'm gonna run a command now. Okay. Okay, so let's say I'm running a batch job, or somebody says that hey, I want to update my customer's credit limit, and that will take a long time. I'm gonna say I want to go through the whole customers table. It's not partitioned, and all customers who are really old customers, double their credit limit. Okay, that's a pretty long query. When I click refresh, this update statement shows up here, right? It took a while to run. Okay, you see it automatically kicked in because it ran for more than 25 seconds. You see, it has used over 10 seconds of CPU and so on. Okay, and now let's pretend that I'm another user who also wants to update credit limits, but let me just, you don't see it on your screen, but so now I'm a different admin who wants to reduce the credit limit of different users. Any customer who's been, basically it's a different query, right? So I want to reduce the credit limit for any customer who's signed up before 2012 or whatever. Okay, so what I want to show you now is this. So this query is running, right? So I think it's been more than 5 seconds, right? So let's look into SQL monitoring. So I keep refreshing and nothing shows up. And this is, I could actually query this manually as well, but I'm just gonna save time. So this query should eventually show up here, but it has not shown up. And this time it's not the UI problem because I've designed this. So this guy has been running for a long time. Whenever, when I troubleshoot stuff, whenever I want to know why is this session stuck or what is it doing, I go to session level. If I know the session ID of this batch job, it's seed 17 in this case, I can just say, show me what session 17 is doing. I query $V session, or I could do something like Ash. I'm going to show you the Ash stuff next week, right? Or I run Snapper, or you could even run SQL Trace, even though when your session is hung, then it's less useful. Because you see what's going on here. So this session 17, so this particular query, so this session 17, who's running it, has been waiting for a TX lock for the last 74 seconds. Or actually, as I keep talking, it's longer. For the last 2 minutes, this session 17 on the right side has been actually hung. It hasn't done any work. And when I look into, this SQL ID, the SQL ID, what it's running right now, okay? So this SQL ID, what it's running, in this case, it looks like, well, that's weird. It doesn't even show that we have started the execution yet, but well, I'm not going to go there just yet. So, I mean, we must be in the execution mode. Did you hit the lock like this? But so let's figure this out some other day. So, it might be a bug with the, monitoring. But anyway, so what we see here is that this session has been hung waiting for a lock. And when I look into the SQL ID level, it tells me that it's only used like 0.05 seconds of CPU. And the IO time is also really small, less than a second, like 0.02 seconds. So the elapsed time, the total response time, it's been 2 minutes, because we've been waiting for the lock. But the actual time spent working, using CPU or doing IO, waiting for IOs, that's really low because we immediately got stuck waiting for the lock, right? And now when you look into the SQL Mon threshold parameter, you see I'm coming back to this. So this is not the total elapsed time. This is the CPU and IO time. That only when the CPU and IO time, you add it together for an execution, if that goes beyond 5 seconds, then the monitoring starts. Okay. Basically, what I'm showing you here is that when you see this guy is still stuck waiting, nothing has shown up in SQL monitoring here because my query here is not actually working. It's stuck waiting for a lock, and the query has not yet used more than 5 seconds of CPU and IO time. So, and the reason is because in the other session where I first did the first update, I did not commit it, right? Let me roll it back so that once the rollback finishes, then this waiting session here, will continue working. So the rollback probably takes also 25 seconds or around that. Okay, rollback is complete. Now the other session probably has continued. So when I run the so the other session finished in 5 seconds, 5.3 seconds. So, and when I click refresh, you see the other query showed up. And now, the query the monitoring finally kicked in after we used more than 5 seconds of IO and wait times. And when you, not sure if you see that, but when you drill down into that, you see it says the application wait time is 5.4 minutes. So there was a question, why does it say 5.6 minutes? Well, the query took 5.6 minutes to complete because most of the time it was waiting for a lock. But it started waiting for the lock before it had used enough CPU and IO for the SQL monitoring to kick in, right? So basically what I'm saying here is that if your query is waiting for a lock before it has done enough IO and CPU usage, then it doesn't show up in SQL monitoring. But then you use the traditional approach. You just go to session level. You query what this session is doing. You run Snapper or Ashtop, and I'll talk about that next week. Okay. So that's why. So this that's why I'm talking about CPU plus IO, not all wait events. Okay. You see, if I move my mouse to the CPU little item here, it's 5.4 seconds. And actually, let me open it up as well. Okay, so this is now. I did not want to demo that either. I deliberately made the SGA small to kind of demo something else in past. So apparently it uses a shared server. It wants to use hash join area, hash join memory in the large pool, because OEM probably uses a shared server. Oh man, so I didn't want to demo that. So, well, this is a hacking session, right? Demos tend to go sometimes wrong. Let's see if it opens up. Oh man, so let me roll back. Let me make sure that I'm querying work areas and a large pool, so that's let me see how many sessions I have logged in here. So, and obviously when I ran through all these tests like a couple of hours ago, then everything worked. So, but let me just see. And this is probably just an issue because I've made my SGA really small for Oracle 18, right? So what I'm gonna just do 670. So the error message says that my SQL monitoring wanted to use hash area, the big, stuff that's usually PGA in the PGA, unless if you're using a shared server. So, and I think Enterprise Manager here is using, the shared servers with all the XDB stuff and so on. And shared servers put their UGA into large pool, right? And because I've made my SGA so small, now I'm hitting a problem. And I think the fastest way to move on is I'll add more memory. I don't want to start troubleshooting that because then we won't have much time for other stuff or the planned stuff. So meter SG max size. Oh yeah, so I gotta restart this instance in this case. I could try to let me do something silly. So on this older system, flush shared pool, but I expect this to not help really because large pool is separate, right? And then when I do flush shared pool, then it's not going to flush out other shared sessions UGAs from there, right? So that's unlikely going to help, except if this allows me to grow the large pool at the expense of shared pool. I don't have high hopes. And I wouldn't rule out some sort of a memory leak either. But again, I'm really having only a 600 meg SGA for Oracle 18, right? So then that's that's gonna end. You'll end up in trouble. So, well, it hasn't failed yet. So maybe it's growing. Maybe it's extending the large pool subheap at the expense of, let me see, large pool is growing at, well, it's 1232 when I query $, memory dynamic components. Large pool has well, it's trying to grow at this time, right? And it's been growing at the expense of buffer cache. I guess I know what might be going on because I ran a benchmark here as well, so which did a lot of I/O, and then the buffer cache grew, and perhaps that's what shrank the large pool, which at some point was 128 megs. It shrank it to 32, and now we got an error for some reason. But this still doesn't work, so. I think this. I think the faster way to move for now is to just allow Oracle 18 to use a reasonable amount of memory. So so I shut down my other database. I can use 1200 megs. So alter system set SG target equals yeah. I'm not usually a fan of fixing problems by increasing parameters like that, but you know, I know that it's ridiculously small in my laptop. So, and now I gotta restart this thing as well. So just make sure. Yep, this guy is still loading. It's probably trying to extend the large pool heap, trying to flush out a bunch of stuff from shared pool. Okay. While this action is going, then let's go through some questions. So Bob asked if my scripts are downloadable. Yep. Go to my blog, blog.tunnelbutter.com, downloads, and you can either download all my scripts as a zip file, or you just can go to GitHub. So I would recommend you start using GitHub and just clone my repository, because then you can pull changes every week or whatever, and you'll see what I've changed. You know, I usually add comments as well with what I've changed. Okay, so all my scripts are downloadable. Those scripts I'm showing you today, I have updated a few. They are all there. I have updated a few, so I'm gonna commit the latest updates to GitHub as well. Okay. Just go to my blog. Palava, yes, querying the database directly is always better than using OEM. I mean, OEM is great for when you need graphical overviews and trends. Well, you know, I guess trends like this. Well, this is not very visual trend. But when these tools seem to lie or they are weird, then I always go to the source. I query the $V or DBA hist views directly. Okay. So Rostislav, if I said your name correctly, thanks for that comment. It's not, if nothing is wrong during a live demo, then it wasn't a live demo. So that's how I view it as well, and that's why I call these things hacking sessions. Okay, so I think I set this parameter for a wrong instance actually. Did I? Oh man, you know, this actually gets more complex because I gotta log into the container database and do that. Okay. I was not in the container database. You know, because in a CDB multi-tenant instance, actually you have only one big SGA. You can have like 7 pluggable databases in there, but the SGA is still one. You know, shared pool is shared by all PDBs and so on. So individual PDBs cannot really control you know, the SGA target. So I had to run this command while logged in to the container database, and I have I have a special alias for that. Okay. Okay, you see now when I ran the alter system command in the container database, then in the CDB top level container, so to speak, now this is honored. Okay, and we can hopefully continue. So if I look into, I got a lot. I have some alter Okay, nothing seems to be wrong with this database, so that's good. Let's try to log in again. Okay, we are back in business, I hope. And now what did I want to show? So I wanted to show the old monitored query. However, I think, I know that it is gone from memory. So, because the real-time SQL monitoring, the standard way how it works is that it only queries $v$ views, $v$ SQL monitoring views. And you see, it doesn't have anything here because I restarted the instance, right? So, and apparently nothing got persisted in AWR either. So as I'm here, I'm gonna just quickly show you a slide. So basically this is where I was. This is what I showed you previously. And since I just restarted my instance and the memory $v$ views were empty, so I cannot go to my old report anymore. I have to rerun the query. But in that context, it's worth mentioning that in Oracle 12c, Oracle can store, whenever AWR snapshots happen, right? Then Oracle can take some of your top longest running queries and persist the SQL monitoring reports as CLOBs, into some data dictionary tables as well. And when you see Mauro's blog entry, then and that's in my SlideShare page as well, you'll see that. So when you select an older time period, you can see some of the top SQLs from there, right? But not everything gets persisted, so it's not always super reliable. So that's good in Oracle 12c. What I would do here is, let's say, select time period. Real time, when you click on the time period here, real time comes from the $v$ views in memory, but let's see if I do the historical one. You see, this now takes a whole day, and whatever has been persisted, I can see here, right? And even though it's not I need to actually, what I wanted to show was the update statement, but now it's gone from memory, so I'm not going to rerun that. But at least now the reports open up, so that's good. So we don't hit this memory error anymore. Okay, so let me just go back. So hopefully you at least, despite this messy demo effects, let me go back to the real time. So let's read from memory. Hopefully, you learned a few things, and one thing is that SQL monitoring reports, unless you force them with monitor hint, or unless it's a parallel query, if it's a parallel query, then usually SQL monitoring reports, they don't immediately kick in. They kick in only after 5 seconds of CPU and IO usage, right? And if you're stuck waiting for a lock before you even get started with the main parts of your query, then it might not show up in SQL monitoring at all. Okay, so this is what I wanted to say about when does SQL monitoring kick in. So let's go on now. So as a next phase, let me log in. Let's see how to do this. Okay, so I'm gonna do set auto trace stat. Okay, and I will just do select star from, and I'm gonna say monitor as well. I want to force monitoring, right? And I'm gonna say select star from, I don't know, order entry customers. Okay, so this is a long-running query, or will, as you'll see. Okay, because as you see, I'm actually doing just select star. I'm taking everything, right? And I have forced the monitor hint. So now when I go back here, thanks to the monitoring hint, this query has showed up. It actually showed up immediately. It didn't wait for 5 seconds or anything like that, right? And let me now drill down into that. Do you see something weird here? It's the duration, the actual runtime, the duration of the query is 51 seconds, but we only have used 15 seconds of database time. So we have, so there is this duration which is much longer. Visually, you don't see that, but it's much longer than the actual amount of CPU or weights used in the database. And where does that come from? So I actually have a slide about that as well. So let me just jump right in there. I'll skip some of these items. Okay. Whenever you see, here is on a slide a similar scenario. The duration is much shorter than the database time. Sorry, this is so the duration is much longer here. You see it's 15 seconds here, and database time is only 1.3 seconds, right? But on my example, you see the duration is already 2 minutes, and database time is only 30 seconds. And as the slide showed, whenever you see that, then the first thing where you look at is this. How many fetches have you done? Because the duration, let me see if I have it on a slide. Again, I'm sharing it on the I'm showing you it to you here as well, but that's all in the slides here. So the duration, the upper number in SQL monitoring, that's the amount of wall clock time from the SQL execution start all the way to when you close the cursor or when you reach the end of data, right? So you can open a cursor and keep it open for 2 days and do nothing, and the duration will just keep going and going and going. So the cursor has been open for that long. But if you don't really do much, you only maybe fetch once and then you are idle, not fetching anymore, the DB time is not going to go up, because DB time only goes up when you actually do work in the database. If you do activity, you use CPU, you wait for IO, you wait for this and that, right? But if your session is idle, waiting for the next fetch command to come in, then the DB time is not going to go up. So when the DB time, the actual activity, actual time used in the database, when that's way shorter than the duration, then the first thing to look at is, okay, how many fetches have we done? Right? And in this demo, when you look into the actual number of records returned, you see the select statement has returned 332,000 records to the fetch operator, right? And we've done 33,000 fetches. Then we can calculate, right? So just give me a second. So we can calculate. So 332,000 divided by 33167. It's about 10. So it looks like we have fetched around 10 records per fetch operation, right? Because we've done that many fetches, and the total number of records returned to the fetch operator from this select statement has been this. So it looks like the array size or the fetch size has been 10 records at a time, right? And if my report actually needs to fetch that many records and dump them somewhere, then, one way to tune this is use a bigger array size, configure your, client library or Java code, whatever, to just fetch more records at a time, okay? And that's exactly what happened here as well. You see, we fetched 10 million records, 20,000 fetches. So in this case, I have my array size in my SQL Plus is 500. I fetch 500 records in one round trip, okay? And when you look into the wait events, it's CPU and it's SQL net more data to client. Sorry if it's too small, but you see, because I'm fetching so big array sizes, 500, records at a time, then I've ended up, waiting for, the TCP send buffering as well, right? That send more records, send more packets back to the client for every fetch. Okay. So, and you see, this is a full table scan. I'm doing a select star, so there is nothing much to tune. I mean, I cannot really tune the execution plan of this statement. If I want to make this guy faster, then, well, either I return less records or not do a select star. Maybe I don't need to return that wide records. Maybe only some columns are enough. That means less network throughput, right? Or I fetch in bigger array sizes. I can set the array size even bigger. Or move the client closer to the server, right? So it doesn't go over the long distance network and so on. Okay. So there is a question that how do you check the client size, array size? So I don't know of a good way what you could just, I don't know how you could, so how do you put it? So the client can, when client starts fetching, they can set whatever they want for the array size. So there is no $view which tells you exactly that this client or this session has such an array size, because different, queries, different parts of the app may use a different array size, right? But from here, you can already calculate it. If 10 million records were returned using 20,000 fetches, then you divide it. It means on average, we fetched 500 records at a time. Or you just, you go to $SQL. So, you can get this kind of stuff from StatsPack or AWR as well. I'm querying $SQL, and I'm querying rows processed and fetches. You see, for that query, it's been executed only once, and across this one execution, we've processed, the select statement has returned that many records, and it's been returned across that many fetches, and rows per fetch is, very close to 500. It's actually 500, I know, but perhaps the last fetch or, and the first fetch, they were less. The first fetch tends to be one record, and then it just keeps going. Depends on number of things. So you can indirectly look into queries in SQL and kind of derive the fetch size from there. And part of course, if you can enable SQL trace, then SQL trace. I'll just reply to you all. The SQL trace, the raw SQL trace tells you there's a column called R in there and tells you how many records were returned. So if you fetch a lot of records, it shows you the array size, right? So with $views you can indirectly derive it, but with SQL trace it's a bit more precise. With SQL trace still though, that if your array size is 500, but the query itself only returns 20 records and then it's done, then you'll see 20 there, not 500. So, but it's pretty much the same with $views as well. Okay, so that's what I wanted to show about this. So, and that's part of the explanation or the intro what I had, or the description I had in my blog, that there are other things to check. You don't, before I jump into tuning the execution plan itself and wondering, why are we, sending many more records back than the optimizer estimated or whatnot, then before I do that, I look into these other things as well. I'll see that for how long has this cursor been open. You see, you can easily demo this kind of thing. So I just say open C for var C ref cursor exec open C for select monitor star from customers. Okay, and well, actually, let me just customer ID and var and number exec fetch C into N. Okay, so what I did here is that I opened the cursor and I actually ran the fetch as well. Now it's actually executing as well. Because if I don't fetch something, then it's just opening a cursor, doesn't actually run it, you know, when it's a select statement. So let me see if it now shows up. You see? Well, this even ends up a parallel query, so that, you know, complicates things. But if I refresh, you see the query has been running. I mean, the duration, you know, that it's 43 seconds, and the database time is 5.1 milliseconds, not seconds, milliseconds. This query hasn't done much yet. It has only you know, started a full table scan, and it only has taken one record from it, and then it's idle. You know, now it's waiting for the next fetch to come in. So if I refresh, so this database time is not gonna go up until when I fetch some more. You know, the GUI refresh apparently doesn't always refresh, but or perhaps it well, let's just do one more fetch. Now we have the next, you know, value in here. Let's do one more fetch. You see, now we have the next value. Let's refresh. You see the duration has gone up, but even the database time, I guess it's, you know, it's so fast, so that the you know, now that it has opened a block and or, you know, it's probably has some sort of a buffer of records or a row set allocated somewhere. Maybe the next fetch was so fast that it doesn't even drive this number up anymore. So if I just do, I could run this in a loop or something. And the fact that it's a parallel query, that makes things harder, because there's probably a buffer somewhere in between, and now we just read a record from the buffer. But basically where I'm getting at is that, let me just open it up. You see, duration is 2.5 minutes. Database time is 5.3 milliseconds, right? It's really small. And you know, so basically, we haven't done much active work in the database, only a few milliseconds worth. However, the cursor has been open for 2.8 minutes already. So the cursor has been open for a long time. And you see, we see like 22 fetches have been done that, you know, meanwhile. If I trace this, like with SQL trace, I would see really long waits, really long SQLnet next message from client or SQLnet message from client waits in between, because the session is idle waiting for the next fetch or whatever command to come in. Okay. And the moment I close the cursor, or when I reach the end of data, then you know, then the query finishes, so to speak. You see, now it's done. It only has actually returned 22 records, and you see the parallel slaves have probably, you kind of fetched a bigger buffer full of data, but I only fetched you know, one record at a time, so that's why this number is smaller, right? And the total database time is only 0.2 seconds, 200 milliseconds. Okay. And Mohan, yes, these kind of slow fetches what I just demoed, they lead to Aura 1555 errors, snapshot too old as well. Because if you only have undo to cover half an hour, and now somebody fetches slowly for 5 hours, then they might eventually end with this, not enough undo to apply condition, right? Or a 1555, right? And the answer there is to tune. Don't make your undo table spaces bigger. Make your queries run faster. Make the queries fetch faster. Sometimes people use like an order by trick, so they do an order by in the end, so that we will fetch everything and dump it to temp and order it as well. And when you now later slowly fetch it from temp, then consistent reads don't apply there anymore because it's like private stuff, right? Okay, so that much for this. The next part I will show on a slide just to save time. What if the DB time is much bigger than the duration? What if we have the opposite scenario, right? What if we have the opposite scenario? You see, the database time is almost 36 seconds, but duration is 4 times less. Well, when that happens, then likely we are dealing with a parallel query. Because you see, in this case, yes, indeed, we have 4 parallel, the parallel degree is 4, which means that you can have, 4 times something slaves. You can actually have more than 4. In this example, we have 8, right? This is how parallel queries work. They can sort of parallelize multiple sections of your query plan at the same time. And in this case, without going too much into details, indeed, when I click on the parallel tab and when I expand the parallel set, you see it looks like that there is one set of slaves. These are usually the ones who scan the table and produce rows for the higher set. And the higher set usually consumes rows and then computes something with this. And in my case, it's just count distinct or something like that, right? And indeed, in this case, it looks like one slave has used 9 seconds of database time, active CPU usage and IO waits. And other one used 9 seconds at the same time, a different CPU, right? And this guy's also used roughly 9 seconds. So in this case, you see the database time is 4 times larger than the actual human wall clock runtime of the query. You see, we only have one fetch. We don't have this kind of fetching problem here. DB time can be much bigger than duration when you have many processes working for your query at the same time. That's what parallel slaves do, right? So the DB time should not be able to grow more than 9 times in this case. So, hypothetically, you could have all these 4 slaves fully doing something on CPU or waiting for IO. You could hypothetically have all these 4 slaves also doing something at the same time without going to sleep or being idle. And you could also have query coordinator, hypothetically, fully busy doing serial stuff, right, in the plan, right, or coordinating stuff, right? So then the theoretical maximum should be 9 times whatever is the duration, right? But in this case, it's like the scanners or the producers have been very busy, but consumers have been sort of slowly doing a little bit of work, and mostly they have been sleeping, waiting for more records from the lower layer. Okay, so that's parallel query. So I really plan to not go over time. But because we had this shared pool crap showing up, then I'll go up for a few more minutes, and I'm gonna upload the video right to YouTube. So if you have to go, then you'll see that as well. Okay. So I'm gonna skip some of this stuff. I want to show you more complicated things. So you're gonna like this. So the next thing is, let's do this. I'm just gonna log in. Okay, so I'm gonna run another update. So let's see. let's say that we have a credit card number. Oops, I haven't run it yet. So let's say we have a credit card number, like or card ID, and one customer, their card expired or they lost it, and now we have to update the credit card number to or the credit card ID to something else for all their orders what they've placed. Okay, so this is a pretty straightforward example. Let's see if it shows up. I added the monitor hint here as well, so the monitoring would kick in immediately, right? And I want to demo something. So this is the update. Just expand it. Okay, so this is something yet different. So I'm going to talk to you about why there's some small discrepancies here in a moment. So that's a separate thing, but you see, let's ignore this for now. So when I just run this update, you see we found 9 records, right? We found 9 records to update. We scanned through the whole table. This table happens to be, even though it shows 2 gigabytes, it's rounded up. It's actually 1.6 gigabytes. I can show you. The segment, orders table segment is 1.6 gigabytes, right? SQL monitoring just, I guess, when it's more than a gigabyte, it starts rounding up. But when you move your mouse over, you see it's 1.6 in this very small text. That's how many bytes they read. Okay, so everything is normal here. We scanned through millions and millions of records, 1.6 gigabytes. We found 9 records to update, right? This whole thing, every line here in the execution plan has been executed only once, because usually when you see starts or executions is more than one, that means that there is some nested loop or filter loop or some sort of a loop which revisits this row source and reruns it or rescans it or scans a different partition of the same table. But this is a so straightforward plan that every step here has been only started or executed once, because there is no need to scan through the table multiple times. Okay. Let me see if I let me just click on this once more. Let's see if it refreshes. Yeah, it's interesting. Normally, I should see numbers here, like the actual rows, because this table sends 9 row IDs, whatever match the filter condition, it sends it to the update statement, and the update then updates them, and we should actually see 9 records here. So that's weird why it's not showing up. I'm gonna query my own session. I'm using this text mode. That's some SQL monitoring glitch probably, right? So I'm not gonna troubleshoot this for now. So anyway, so that's nice, right? So, well, it shows this, but now I will do a slight variation. So I did a rollback, right? So I undid everything, right? Okay. Yeah, so Mohan, actually, you mentioned maybe I should commit, and then the commit actually, because of the in-memory undo and so on, the changes are actually applied to the block and so on. So we can test this separately. That may be the reason, right? But I want to demo you something else first. So I'm going to do the same thing, but first I will simulate the scenario that so I didn't want to commit this. Okay, I have two windows here. So the left side window is the same update, which goes through the whole table and updates the credit card number to something different for all orders of where this credit card was used. But before I do that, I will run. So see, I'm in a different window. I'm going to update only one order. I'm going to only update one order, and I'll set the the credit card to something different. Okay, and now what I'll do is this. I'll commit. Sorry, actually in the other order. So I will run the update now. I will run the same long full table scan update. And the moment I run it, I will also issue commit in the other session. So update, commit. So the left side update started, and immediately after that, I ran a commit. Let's see if my demo worked. Suspiciously fast. 109, is that the one? I think I didn't do it fast enough, so let me just do a rollback here. So select. Let me just try to reproduce this demo again. If not, then I'm just going to show you a SQL Mon report. It's really interesting. So where order ID equals, do I have a previous order? Okay, so I'm going to try this with a previous order. So let's see if it works. Then I'll explain what the hell I'm doing here. So on the left side, I want to update all credit cards where credit card number is this. And I want to update it to this 10,000 or 10 million, right? And in another session, I'm going to modify one record, and I'll make the credit card number into this number, what the first session will be looking for, right? And I can, let me just say, so I can run this, I can already run the update command, but the commit needs to happen after the big update starts. So I'm going to run this big update commit. Let's see how long it takes now. So I ran this, and immediately, or very soon after, I ran the commit as well. Oh man, it's still too fast. So I think this demo failed as well. Let me just see. I think I'm gonna have to record this as a video because again, as usual, it worked before I showed, but before I did it live. But maybe I forgot to reset something. So let me show you something what I previously recorded. Two previous SQL statements. You see, this is an example where I run an update, and you see it updates 9 records. It scans through 1.6 gigabytes. Right, this is the same update that I ran. And now when I did this trick, it's the same update statement. It's the same update statement, but for some reason it took 36 seconds, right? And you see, and it has read 3 times more, close to 5 gigabytes of data. So instead of 1.6 gigabytes, the same update statement against the same table has read, it looks like it has done 3 full table scans. It's a single update command. It's not 3 executions, because SQL monitoring shows only 1 execution at a time. It doesn't show you like a sum of all executions over an hour. And you see, you should never see this kind of stuff. Within the single execution of this query, what I did earlier this morning, under the hood, the update attempt has been tried 3 times. You see, the previous, when everything was fast, everything was done once. I did only 1 full table scan and I read about 1.6 gigabytes of data. But now the single update statement, for some reason, has done the full table scan 3 times in a row for a single execution. And it has done that much I/O. And that's why I tried to do this timing thing, that I wanted to quickly run a little update right after the big update had started. But I may have forgotten to reset something, or maybe I did it in wrong order now that I do it in live. But basically, this is what write consistency is. I mean, Tom Kite wrote about it like 10 years or more ago, 15 years perhaps. In addition to read consistency, there is also something called write consistency. That when you start a big update and you find a record which matches what you wanted to update, but since by the time your big update gets there, somebody else has changed that record and committed it to something else. Now what I should do? I mean, I cannot just ignore it, because it used to be the value what I wanted. I can't just ignore it, and I cannot go and update it to something else either, because somebody else has changed it already. So when you have this big long-running update and small updates modifying the same data, the same records you are looking for, then write consistency clashes may happen. And what that means is that when a big update or a merge statement hits a problem, it cannot just ignore this one record. It will roll back the whole statement and it will try again. And in order to avoid trying again 1,000 times in a busy system, it actually, when it hits the write consistency condition, it rolls back the first update attempt. Then it will do a select for update under the hood, essentially. So it can lock all the records it wants to access, right? And then it does a final update. And that's when SQL monitoring would show you that you should never see more than one here. I mean, this update statement is executed only once by the user, but under the hood we've had a rollback, an update, rollback, select for update, and then a full update followed by that, and then we commit. And that's why, because we don't have any indexes here, you see we've done the full table scan 3 times. So search for write consistency Tom Kite, and you'll find the article which explains it. Unfortunately, my demo failed, but I think I'll record a separate little short demo for that. Okay. So yes, the short update should be triggered after the big one starts, but I think the commit needs to. Maybe that's what I did wrong, but I think that you can do the short update. I made this short update the record, which was so called in the end of the table. So I knew that the big full table scan wouldn't reach it there that quickly, but perhaps it did. So yeah, that's it. Bartosz asked, does it mean that the undo table space was not read? It was. I mean, when we run updates or deletes or merge or whatever, then first you will have to find records, right? You will have to find records where, this condition is true. So this is like executed like a select. This is like a select part of update. It uses consistent reads, right? It uses consistent reads to find data which was where the value was, this as of when the update started, right? And then it finds a record where the value was this like 5 minutes ago when we started. But now when we try to update this block, we cannot do a consistent read anymore. If I want to update the block, I have to see a current latest version of the block. And if the current latest version, the value in the current latest version of the block has changed since since the query started, then we hit the write consistency problem. And it's only a problem when that particular row that you want to update has this problem. If some other row in the same block has been changed, you won't care if that doesn't match your where clause, right? So that's what write consistency is. And SQL monitoring, helps you to see that, because sometimes when you have these really big updates or merges, and you can monitor for that. Look for any statements where the update or the top level value here is more than 1. Okay, so I'm 20 minutes over time. I'll show you one last thing, and then we're gonna leave the remaining stuff into the Ash class, right? And my training, of course, right? So that's part of the reason why I do this stuff. When you read Maria Colgan's articles, it explains a lot of good things there as well. So, but let's get really geeky for a second. I have an old Oracle 11 SQL monitoring report, and I have a script called SQL Mon, which is explained on my slide, and then Maria's article mentions it as well. You can save the SQL monitoring reports to disk, right? And this is actually a Gluent version where we have the big data backend or Hadoop backend data shown here as well. But anyway, so the cool thing is that, sometimes I want more information that's displayed in Flash, right? I can click on the plan, and I can click on the filters, and I see the projection, which columns are taken, and so on. But sometimes when the output is very wide here, it's pretty hard to read, right? So then what you can do is you can, if it's 11G report saved like that, you can just open it up and just see the SQL monitoring report is sort of stored here as HTML or XML or whatever. It has a lot of this. All the stuff you see on the screen and all the stuff you can click on, that's actually data here, right? So, and just disable the syntax. So this is something that you don't see in the Flash really. If you want to see the outline data as well, that what kind of transformations, or what kind of query transformations, or what join orders were picked and stuff like that. Some of this stuff, in addition to the plan shape, you might want to see extra info. So you can actually open up the HTML file yourself. You see the projection. You can actually get the data from here. Well, it might need a bit of editing, but it's sometimes more convenient than just scrolling left and right in this small boxes what SQL monitoring gives you, right? So that's 11. But now when you want to open up a Oracle 12 version, okay, I've saved. So by the way, if this also works actually, but only if you have saved. You see, it's the similar data, SQL exec start and blah blah blah, but it only, So where do you go? So when you go to Enterprise Manager and you save the report, I guess you could even just do right click and view page source. Nope, it's probably like a frame here, so that's not as easy as to view. But if you use a SQL Mon script, like in my slides, to save a SQL monitoring report, then what happens is this. So just open a random one. So let me just take, I don't know, this guy. And you see, when you use the SQL Mon script, then what Oracle does, it actually encodes the data. So you see, it's the SQL monitoring report data, but it's encoded in base 64 and it's compressed with zlib, right? And when somebody sends you that, and you know, you cannot really read that. But basically, what you can do is you just edit this. You just take only you remove all the other HTML stuff. You only leave the base 64 data. Okay. So, and now I say base 64 minus decode this file and put it into a, I don't know, SQLmon.z, because it's still zlib encoded, right? So now you could just say, hey, I'm going to do a gunzip of this, but gunzip says, hey, even though gunzip uses zlib under the hood itself, it says, hey, I don't recognize it, because even though it's compressed by zlib, it does not have the gunzip header. So, but luckily there is a parallel gzip, pigs. If you search for that, it exists for Windows and Linux and Mac OS, parallel gzip, and it has a ungzip option as well. So I just do this. Okay, so you see, I took this base 64 encoded stuff from the HTML file. I base 64 decoded it, and I ran this parallel gzip, which is a bit smarter than gunzip. And now in this file here, SQLmon is actually the SQL monitor, raw data. I see the SQL text from here. I see all the other SQLmon data, including the outline information. Okay. So only 20 minutes or 27 minutes over time this time. So it's, well, I guess going as usual. So yeah, so the write consistency, it did work in my demo, but I'll just try it again. I'll record a small video about it. And it was actually, it was Tom Kite like 10-15 years ago when he sort of discovered it, to his surprise. And then he went to talk to the kernel developers, and they explained why. It is there for consistency reasons. You cannot update a record which was what you wanted it to be at the time, but since you got to that record and you wanted to update it, somebody had changed it to something else. After your query started, right? So that's very interesting. Okay. Let's see what else. We'll talk about Ashtop next week. Kunvar asked that if you transfer the DBA history reports from one database to another, can you kind of use it there? You see, the DBA history report details, that's where the stuff is kept. Oracle keeps the report as a club, so it doesn't save the $SQL monitor view and regenerate the report. Only during the AWR snapshots, it takes some top statements and it generates a SQLmon report, and it stores it in a club, right? Apparently in a compressed blob as well. Basically the kind of the files what I just showed you. It basically saves the whole HTML file in a club, right? So in that light, yes, you can use a database link or something, or export to copy this to some other database if you want to analyze them somewhere else. But basically, but you cannot use OEM anymore on that. But you know, as it's a club, you can just save it to disk. You spool it to disk, and you can open it from there. Because if you look into my SQL Mon, let me just run it on myself. Username, sorry. See it, my own session. Whatever was last monitored in my own session, I'm gonna run SQL Mon on that. You see, the SQL Mon query actually spooled. It selected data from this $SQL, or you know, it used this report package, and if whatever the output was, it was actually a club as well, and it spooled it to disk into this file, and then it opened it up, right? And similarly, you can spool, you know, any club to disk. And you know, perhaps the AWR warehouse product, I think it's free to use, you know, or not separate licensed. AWR warehouse can pull in AWR data and Ash data from many databases into one big central performance repository, right? Perhaps it pulls these clubs as well. I haven't checked, but it pulls all kinds of other metrics. Okay. So will I be sharing the demo steps? Yeah, I mean, well, I have these in the video, and these update statements I ran, I can just paste them into a blog entry when I announce the video, right? And I'll put the links in there as well. So, but you still probably would need to view the video to see in which exact order I did this. Okay. Enrique, about an earlier comment, actual rows is 0 versus 9. Why don't we have a 9 here? And Enrique's comment is that, you know, perhaps it's because it's not a select and it's an update, right? And it's a good point in the sense that you know, update, you know, the bottom line here is the select part. I mean, every DML statement, or you know, every update, delete, and merge, they have like a select part as well. You know, they first find those records where this where clause is true, right? And then the row IDs and whatever columns needed of those records which are matching, these will be sent to the update statement. And update now updates the records, but doesn't have to send them back up, right? So it only has to send the row count back. But this is my memory is kind of failing me. I thought that I would see 1 here or something. So you know, with the row count. But let's try once more. So I'll just say update monitor this, and I'm gonna run commit as well right away. There is 10 rows. Okay, 10 rows updated because I mucked around with the data, right? So in the other window I updated this one record, right? So, and if I run now, let's just use SQL Mon. Oh, let's use the GUI then. Yeah, still 0. So So I think Enrique, your comment is correct. So I just remembered that it should show 1 here, and the 1 is actually the you know, the number of the row count sent back. But I think I probably mixed it up with selects. Oops. I mixed it up with a select. If I do a select, you know, let's say select monitor count star from SOE orders. If well, obviously I'm not going to do a set here. If I do a count star like this, then Oracle scans through the millions and millions of records I have in this table. well, that's even a better way to show that that gets more complicated. I guess because I updated. Did I miss? I set it to 10 million. So let me just. So let's first search for 10 million, because now we should have 10 records. I'm going to run SQL Mon on command line for myself, so I don't have to click around. It opens the default browser and so on. So, but you have to have this script running on your workstation, not in a Linux server somewhere, because otherwise you cannot, I use SQL Plus to spool the file. Instead of FTP, I use SQL Plus to spool the file locally. Anyway, so you see when I do a select, then, this is, you go through millions of records, you return 10 records for counting, and now you count them, and you return only one record back with the actual count. You see, because we returned, we returned only one record, and this record contained the count. And similarly, when I run the previous query, which doesn't get anything, then we should see like a reverse situation. You see 0 rows counted, but 1 row was returned, right? We still had to return and generate 1 row with the count. So when I look into the SQL Mon here, we should see a reverse situation. You see, we scanned through millions of records, applied the filter, didn't find anything, so we returned 0 records for the counter. But the counter said, okay, fair enough, I'm going to return 1 record back to the application, saying that 0, the number you want is 0, right? We got 0 records. Okay, so that's all. I'm going to upload the videos to YouTube, and then I'll write a little blog entry when I'll announce the video, and I'll put these links in there as well, and the commands I used too. Okay, thank you very much, and see you next week. We'll talk about Ash stuff then. Thanks, and bye.